In this recording, we're going to learn how to solve quadratic equations using something called the quadratic formula. Now, the quadratic formula is a pretty powerful tool. It works all the time, unlike factoring, which only works under certain circumstances, if the quadratic equation works out for factoring, right? So this particular thing called the quadratic formula, I'd like you to put a box around it, looks kind of complicated, right? It's got a fraction, it's got a square root, it's got a little thing called a plus or minus, but it has familiar components because the a, b's, and c's that we're referring to come from our standard form of a quadratic equation, which you're familiar with, a, b, and c. Like you're familiar with the properties of a, that it stretches a graph and reflects a graph if it's negative, that c is the y-intercept of the graph. You're familiar that b has a component in the axis of symmetry. In fact, you can see the axis of symmetry equation right here. Check this out. X equals opposite b over 2a. It's sort of built into the quadratic formula. So there's some familiarity here, even though the whole thing is a little unfamiliar. So I'm going to teach you a song, matter of fact. You learned the alphabet probably by learning a song to learn your ABCs. Well, this quadratic formula is not too hard to use if you memorize it correctly. So I'm going to teach you the song. It goes like this. X equals opposite b plus or minus square root of b squared minus 4ac all over 2a. All right? And some of you are saying, whoa, that's weird. The teacher sang. That was weird. Yeah, but I'll do anything I need to do to try to help you guys learn. And song helps things stick to your head. So let's sing it one more time. X equals opposite b plus or minus square root of b squared minus 4ac all over 2a. All right, so in order to use this, we need to be able to know what are the a, b, and c parameters of the quadratic equation. So it only works, again, the a, b, and c can only be identified when it's in standard form, when it's equal to 0. So if it's not equal to 0, you need to do a little pre-work to get it equal to 0. And then you can identify your a, b's, and c's. So what I'd like you to do is work out this first one, get it equal to 0, and then identify your a, b, and c, please. Then play the recording. Okay, so hopefully you did this. Okay, so we can identify a, b, and c, keeping in mind b is negative. Okay, now that you know how to do these, can you please work out example 2 and example 3? Play the recording to check your answers. Okay, hopefully you pause, pause and work these out and aren't just watching me do it. We have to get all the terms onto one side. The question is, which side is the right side? Answer, it doesn't matter, but one side or the other. So I'm going to subtract the 3a squared. Of course, there's no like terms here, right? So I just have a 0 on the left side. Okay, so my a is negative 3, b is 10, c is negative 3 also. Now you might say, well, what if I brought these terms over to the left side because I like my 0 on the right side? Of course, that doesn't really matter. You could do that, and you'd end up with 3a squared minus 10a plus 3 equals 0. Notice how this is the same thing, but all the terms are opposite signs. They're all opposites. So in that case, my a would be 3, b would be negative 10, and c would equal 3. And you could do that, and you'd get exactly the right answer. Okay? Finally, which side do we bring our terms to? Doesn't matter. I kind of like stuff on the left, just to force a habit. We can work with terms on the right of the equal sign. So a is 7. Whoa, what's b? There's no x term, there's no linear term, so b must be 0. Check yourself on that one. That's a potential source of error. Okay? So now we're ready to start solving some equations by using the quadratic formula. Okay, so the example I'd like to work on is actually example 2. Okay, well, we can come back to example 1 at some point. Probably have you do that one on your own. So example 2, we're going to start out by getting it in standard form. So please do that. Get 0 on one side. So if you subtracted 15, so we have our 4a squared plus 7a minus 15 equals 0. Now we can identify a, b, and c. Now it's a little weird that a is the variable in the equation, the unknown, but that's okay. We know that a is still the, when we're talking about the parameter a, it's the coefficient of the squared term. So that's a 4, right? B is 7, c is negative 15. Now, this quadratic formula can be looking a little intimidating at first glance, right, when you're new to it. So we can make it less intimidating by breaking it up into 2 manageable chunks. The first chunk I want to work out is this portion under the square root. It has a special name. It's called the discriminant. All right, you don't have to know that name right now, but why not have a name for this thing that we can refer to? And that's the name mathematicians use, and you guys are mathematicians. So this b squared minus 4ac, we can work that out. That's not too bad, right? We can handle that. So we're going to substitute each parameter in its place. So b squared, let's use parentheses every time we square a number. 7 squared minus 4 times a, well, a is 4, times c, well, c is negative 15, so parentheses. Now we just have to do the math, or let our calculator do the math. And a lot of times we'll just pop this in the calculator. So when we do that, it turns out it's 289. All right, well, that's not bad, because now we know the part that in the quadratic formula appears under the square root. So one more time, our quadratic formula song, just to get it stuck in your head so it's useful. X equals opposite b plus or minus square root of b squared minus 4ac all over 2a. All right, so that, now we can work out. X equals opposite b, well, that's easy, negative 7, plus or minus the square root of b squared minus 4ac. Well, that sounds familiar. I think I just worked that out, right? Yeah, we did. It's 289. All over 2 times a. Well, that's easy. A is 4, 2a is 8, right? Easy. Now we just have 3 numbers in this quadratic formula. Now it turns out sometimes when you take the square root of a number, it turns out to be an integer, if it happens to be a perfect square. Let's find out something about the square root of 289. So we're going to go to our calculator, square root of 289. Turns out it's 17. It's a perfect square. It's just not one we utilized a lot. All right, so I can now say x equals negative 7 plus or minus 17 all over 8. Now you might be saying to yourself, what's that plus or minus? Well, it's just shorthand. Because everything else, we know there's going to be 2 solutions, right? There's going to be 2 potential x-intercepts for a quadratic, right? There's 2 places where a quadratic crosses the x-axis. And it turns out they have a relationship. They're both equidistant from that axis of symmetry. So we add and subtract the same amount from that midpoint, that axis of symmetry. So everything up to this point has been the same. So now we're going to split it off into 2 separate equations. X equals negative 7 plus 17 all over 8. X equals negative 7 minus 17 all over 8. And we can do this math. There's like implied parentheses in the numerator. So negative 7 plus 17, 10, right? So 10 over 8. Of course, that simplifies to be 1.25 or 4/5. Now over on this side, negative 7 minus 17. Negative 24. Okay, well that divides evenly by 8, -3. So now we have our two roots. These roots or solutions, or zeros, or x-intercepts, could be checked by graph. They could be checked by substituting back into our equation to make sure they form a true statement. Okay? Thanks for watching.